This video showcases a module for the combined teaching of engineering and architecture students. Engineers and architects spend a lot of time on building projects, and communication and teamwork skills are crucial to a successful career. Historically, the engineer and architect were the same person, before the split between art and science. In modern times, their relationship can be strained, as they each have their own subculture and stereotype. There's a lot of concern about the quality of communication and teamwork skills in graduates. Curiously, the educational system has separated these two professions completely in their formal training. This module is a proactive intervention designed to break down the tribal barriers and begin to improve the dialogue between engineers and architects. The module is taught to a diverse group of typically 100 first years every year. It was carefully designed to ensure constructive alignment between learning outcomes, assessment, content, and teaching and learning strategies. Students participate in a variety of formative and summative group tasks and projects. Firstly, students are presented with the concept of hitchhikers. These are team members who refuse to do their share of the work, but still get the same grade. Then, an icebreaker activity. Students discuss what each profession is typically good at and ideas of how they can work best together. Engineers explain engineering to the architects, and likewise, architects explain architecture to the engineers. Next, teams prepare and sign a team contract. Each team decides on realistic expectations for their group that all members agree to honour. Then, students engage in a role-play activity. It allows them to explore realistic situations they will encounter in their future careers in relation to building projects. For the first summative assessment, students create a poster of free body diagrams depicting forces shown in photographs. They sketch the geometry, add dimensions, forces, and notes explaining their reasoning. The engineers tend to be strong with force diagrams, whereas the architects tend to have better sketching skills. For the second assessment, students participate in a table quiz. Questions are drawn from content delivered in class, and students debate their answers, as would occur in any typical table quiz. Students then perform a precedence study of 5 structural types, and then focus on one in detail. The project focuses on the structural form, layout, loads, and how bending moments and shear forces dictate the overall structure. Architects are familiar with precedence studies, whereas engineers tend to have a better understanding of structural forms and bending moments. For the final assessment, teams design and create a model timber tower to demonstrate stability and how lateral and gravity loads are transferred to ground. Each team is given one sheet of MDF and access to a laser cutter. The goal is to achieve the tallest, lightest, and most load-resisting structure possible. To learn more about this work, see our paper published in the European Journal of Engineering Education. I'm Dr. Jennifer Keenahan from the School of Civil Engineering in University College Dublin.